Is it recording?
Yeah, it's recording.
Right now?
Yeah. I think, right? Let's just check.
No, it's just
Yeah, so this symbol up here means it's recording.
has sound.
Yeah, there's sound. Alright, that doesn't mean we talk the whole time. It's not that cool to hear our own voices. Okay, so here's how we're gonna start. First, our learning target for today is the first learning target of our unit that applies to new material. And it's our first learning target, which says that I can solve multi-step equations with variables on both sides by combining like terms and using the distributive property. You're not going to do all of it today. We're going to introduce solving equations with variables on both sides. Okay. So in this scenario, the square and the equilateral triangle. What does equilateral mean? Equilateral, David. What's equal? What does equilateral mean?
All sides are the same.
Yeah, all sides of this triangle are the same. So we have a square and an equilateral triangle, and they have the same perimeter. So their perimeters, the total of all sides, is the same. We're going to find the value of x. Can you write an expression that represents the perimeter of the square? So last week we actually spent some time on this. How do you represent the perimeter of a square? Or of that square specifically? Perimeter, that square. What do we got? Okay, so what do you get? Perimeter of the square, how can I represent that in an expression?
You could multiply one of the sides by 4.
Perfect. I can actually take the side that I know and multiply it by 4. Why are we able to do that?
Because it is clear all sides are equal.
Because in a square, all sides are the same. That's really the same as adding all 4 sides. That side and that side and that side and that side. Or we can just multiply it by 4. Okay, perfect. How can we represent, not what I want to do. How can we represent the perimeter of the triangle? In the same way that you showed the perimeter of the square, how can you show the perimeter of the triangle?
3 times 3x minus 1.
3 times 3x minus 1. And why 3 instead of 4?
Because the triangle has 3 sides.
Because this triangle only has 3 sides.
And keep in mind that only works for equilateral triangles.
Yep. Because those sides are the same, we can do that. So here's our equation. And now what we're going to focus on is simplifying these equations to solve. How can I simplify that? This goes back to our warm-up. How do we simplify? The only difference now is that that's an equation. Right? There is an equal sign, but we still want to simplify in the same way. How would you start to simplify that equation? Stephanie. I can use the distributive property. Very good. And what would you distribute, Edgar? Okay, be specific. Keep going. Multiply what? 5. Good. And then say it again. And multiply the 4 by 3. And what do you get if you do that?
4x plus 12.
4x plus 12. Great. Can I simplify that side of the equation anymore? No. How about the other side? What can I do over here? Nina.
The same. Multiply both numbers inside of the parentheses
Good. By.
3.
Good. I can multiply everything inside the parentheses by 3. So what will I get when I expand this out? Edgar, go ahead. Good. Because you multiply 3 times a negative 1, you end up with negative 3. So we have an equation here, 4x plus 12 equals 9x minus 3. So we're going to jump a little bit ahead because right now the solution doesn't matter. So I'm going to give you the answer. The solution here is 3. Okay. If I substitute in a 3 for x, do we get a true statement? If I substitute in anywhere I see an x, a 3, what will the left side of my equation be if I substitute in a 3 for x? What do you think? If I plug in a 3 or substitute in a 3 for x, I know you figured out, let's see who else wants to jump in. What do I get? Instead of an x, I'm going to substitute in a 3. Stephanie, what'd you get?
12 plus 12.
Yeah, 4 times 3 is 12 plus 12, so this whole side is 24. How about the other side? If I substitute in, bless you, a 3 for x, what do I get on the right side of my equation? Think about the calculation. What do we think? Do I see a hand? What do you think?
9 times 3 would be 27.
Finish that. You said 9 times 3 is 27.
Subtract that from the 3.
Good, and then take 3 away. 24. What does it mean for that statement to be true? That like 24 equals 24. What does that mean in terms of what I substituted in? If I substitute in a value and my equation says 24 equals 24, what do I know about the value I plugged in? What do I know about 3? It means that 3 is the solution. If I solve for x, x would be 3. But we're going to try to work with this in a different way. So that's the expression, the equation that we have. We can transform this. Now let's focus on this word for a second. Anyone ever see Transformers? Anyone? Yes, no? Yeah. What are transformers? They're cars that transform into robots. What does it mean to transform?
Change into something else.
To change into something else. So let's keep that idea. They're changing. Are they taking away or adding parts when they go from the car to the robot?
No.
No, they're just taking their already existing parts and they're like reworking them to look all crazy, right? So we transform equations the same way. We're essentially the car right now, and we're going to change into the robot, but we're not going to add or take away anything of value. Our value is not going to change. And so both sides of our equation here are going to stay equal when we transform. We can transform this by removing a 4x. So the only difference right now between what you're seeing on the board and what you're used to solving from 7th grade is that there's a variable on both sides here. I can take away the 4x from both sides. Why must I take it away from both sides? Why do I take it away from both sides?
Because in order for it to be equal, you have to do the same to that.
Yeah, in order for my equation to be equal or to stay equal, I have to do the same thing to both sides. So now I've isolated. I removed 4x from here, and I'm left with 12 equals 5x minus 3. If I substitute 3 in for x, what is my equation now? If I substitute in a 3 for x, does the left side of my equation change? No, it's still 12. What's the right side of my equation if I substitute in 3 for x?
15 minus 3 equals 12.
Yes. True statement? Is x still my solution? Or I'm sorry, is 3 still my solution?
Yes.
Wow, I said that with such confidence. 3 is still my solution, which means I can transform an equation. I have not changed the value. My answer will still be the same. What does this equation look like to you? Is that like something you did last year? Or even on Thursday? Because what would we do to solve that? If you were given 12 equals 5x minus 3, what would we identify? We would want to identify what's happening to our variable, and then we undo it from there. I can go one step further. Can I transform that more? Think about how you would solve that. If that was the equation you were given, and most of you feel confident solving when there's a variable on one side, how would you solve that? what would you do? What would you do? How would we solve that equation? Now you can all do it because you learned how to do it in 7th grade, right? And that's what you did the majority of your 7th grade year, was solve equations like that. So how do we do it? Get someone else. Shirley, what do you think?
Variable.
We want to isolate our variable. How can we do that? How can we isolate? What's happening to x? We're multiplying it by 5, and then we're subtracting 3. How can I undo that? Inverse operations. What would you do first? Inverse operations. It's not really fair for the same 4 people to participate because at this point I know that they understand it, but the other 23 of you, I really don't know if you get it. And right now, some of you, while you're looking at the board, there are a good chunk of you that are kind of just looking around the room. And based on the assessment that you took on Friday, you don't have 7th grade skills anymore. Only 2 people in the class passed that exam, that pre-assessment, and that was a 7th grade test. 2 people in the class. So understand why, as teachers, we may be a little alarmed right now, that as honor students, only 2 of you are showing that you understand what you learned in 7th grade. So when we know now that we have the challenge of teaching half the year, you're going to learn all of 8th grade. And the second half of the year, you're going to learn all of 9th grade. Understand why we're concerned. So while I know it's really hot in here and it is disgusting, and I know that it's humid, and I know the weather's going to get better, the only way that we'll have a good understanding that the whole class is together is if other people jump in. That does not mean every time, and I know some of you don't feel comfortable, okay? But even if you're collaborating with someone next to you on that answer, I'm okay as long as you're working through a problem. I know that all of you know how to do this. Some of you may be confused and maybe forget, but I know that you know how to do it. You may just be a little unclear. And even if you're not correct in what you suggest, that's sometimes even better than being right. Because if someone's brave enough to say, I think the answer is 7, and you're not right, there's a good chance other people in the class think the answer is 7 too. So you're actually not only helping yourself, you're helping your classmates. So sometimes it's okay if people are incorrect in their answer. There's nothing wrong with being incorrect. Sometimes it's actually greater for the learning experience if we have wrong ideas so we can figure out why they're wrong. So when we're solving, and now we're not talking, I know it says transform, and we talked about this on Thursday. We identified that variable, we're multiplying it by 5, and we're subtracting 3. What are the 2 things we would have to do to x to get it by itself? What's one of them? Even not in the proper order. Let's just figure out the 2 things that we're going to have to do to x. Edgar, what do you think? Add 3. If we add 3 here, what else do we need to do? Perfect. We're going to add 3 over here. So now I have 15 equals 5x. If I substituted in a 3 here, I would get 15 equals 15. We already know 3 is the answer, but let's finish it. What else do I have to do? Divide by 5, perfect. I totally tried to roll the L and it didn't work. 3 equals x, or x equals 3. So let's see what we did, and this is crazy. Algebra tiles are kind of all over the place, but the concept is still there. Okay? And this is where it gets confusing because not all of us understand the idea of variables on both sides, but I promise you it's the same concept as what you learned in 7th grade. If this was your scale, what would you do to figure out what just one x is? What would you remove or add in? Just the picture. If I need to know what one rectangle, if I needed to know what one is, what could I do? Why 8? Well, I understand what you're saying. You want 1 by itself, but can I remove 8 from here and match that on the other side?
No.
Because whatever I do to one side, I have to do to the other. For those of you that don't like the model as much, you can use the equation and think about what you would do to get the variable by itself. Any ideas? For those of us who like the image. What can I remove? If I knew I needed just one of these, what's a good strategy if I see the same thing on both sides? Think about how you would solve an equation. Because right now the struggle is that there's variables on both sides. But I don't want that. I really only want variables on one side. So what could I do?
Take out the 4x.
Yeah, if I take away 4x from here, what do I have to do on the other side?
Take one for us.
I'm going to take away 4x. 1. So let's write down what we just did. We took away 4x. So I'm left with 12 equals 5x minus 3. Now what? Add what? So I want to add 3. If I add, really? You notice the room is actually so hot that it can't tell the difference between my finger and just the heat of the room. So this is a 0 pair, which means it's gone. If I add another one, no. If I add another one, this would go, and if I added another one, this would go. But I added 3 here. What else do I have to do? I have to add 3 to the other side. This one should work. 3. So what am I left with? 15 equals 5x. And now what can you do? I can divide. If I actually broke these up, we would get 3 to each one. There's 3 there, there's 3 there, 3 here, and you get the point. We break it up into 3. What confuses most students is how to begin, because you're not used to solving with a variable on both sides. Just for the video's purposes, we'll divide them. So x is 3. So we can transform equations, and we want to transform them so that they're in the form x equals, this a means like any number. That's how you solved equations. You've ended up with x equals 7, x equals negative 3, x equals 11. That's how you've solved equations since last year, maybe even the year before. The key difference here, you can add and subtract variables from both sides the same way you added and subtracted numbers. I can really do anything. I can multiply or add or divide one side of an equation, by the other, by anything, as long as I do the same thing to the other side. The reason being, you still need to get the variable on one side of your equation, and when you see the start of these equations, there will be variables on both. So we need to figure out how to get the variables to one side. So we're going to do an example, but we're going to show this step by step. Okay, so here's the process that we just went through. Girls, you can stop writing. First, we distributed. We're going to bypass that a little bit because we've been practicing it and we're getting a lot better. From here, what we did, and Renee, you started us off, we subtracted 4x from both sides. 4x minus 4x gives us 0. So we're left with 12 equals 5x minus 3. This is what you already know how to do. It's the first step that's new. From here, we question what's happening to our variable. How do I undo that? X is being multiplied by 5, and then we're subtracting 3. I'm going to undo that. I'll add 3 to both sides. I'll divide both sides by 5. Is that the only way we could solve? Or is there a way I could start differently? Could I start that solving process differently? Or do I always have to subtract 4x to begin? Another way? Or no?
Could subtract 3.
Good. Think about your operation though, you're a little off. That's not the only way. Okay. Let's say, I'm going to use a different example than yours, okay? Instead of subtracting the 4x, can I subtract the 12? Can I do that? If I subtract 12, what else do I have to do?
Subtract 12 from 3.
Subtract 12 from 3. Good. So now this is gone at 0. I'm left with 4x equals 9x. What's my constant? What's my constant? What's the number now? Negative 15. Perfect. Now what do I have to do? What else? Now, if I subtract the 4, what's the problem with my equation? Let's just show this. If I subtract the 4x, can I have that? No, I still need to balance my equation. So my goal, like on the previous slide, we wanted it to be x equals a constant or the constant equals x. So let's backtrack. And I'm glad you mentioned that because that's a really common thing. A lot of students want to do that. Okay. Where are my constants now? On the right side of the equation or on the left side?
Right side.
Well, they're on the right side. If my constants are on the right, where do my variables have to go? The left. How can I get my variables to the left? If you're not wrong, but if I want to keep my constants here, what do I have to move? If I want negative 15 to stay, what can I get rid of?
9x.
Yeah, I can subtract my 9x. So I will get negative 5x equals negative 15. Now how do I solve? I heard someone say. Divide by,
5. Divide 15 by 5.
what kind of 5?
Negative 5.
By a negative 5. So x equals 3. X still equals 3. The most confusing thing for students to understand, from this point, and this is where a lot of us tend to go crazy, you have 4 options for what you do next. Whatever you do from that point, there will be an actual progression. However, I have 4 options. I could subtract 4x from both sides. I can subtract 12 from both sides. Or I can start here. I can take 9x away from both sides. Or I can add 3 to both sides. That freaks students out. Even in the first class, they're like, no. Like, I don't like having options. They just want to, like, tell me what to do every time. But you have options. And you have to determine based on the solution, or based on the problem that you're solving, which one works best for you. Once you figure out what you're going to start with, it'll all kind of fall into place. But the only difference, and for those of you that are like, I need to get to the solution set, or the way I solve that I learned in 7th grade as fast as possible. Right? I need to get to that method as fast as possible. You would want to remove your variables first. Because even if I moved the 9x, or even if I removed the 9x here, and that was the first thing I did, my equation would be negative 5x plus 12 equals negative 3. Another equation that you would have solved last year, because the variables are on one side. I know it's a lot. Today's not the only day we're doing this. Here's what you're going to try. on your whiteboard. If you don't have a whiteboard, do it in your binder. Here's your problem. Now, intentionally giving you distributive properties so that we can constantly practice. But let's solve that equation. Whatever, go ahead, you try. Solve that equation. Simplify and then try to solve. We'll try to identify where we may get stuck.
Miss Carolina,
Yes.
do you have a better marker?
Yes.
Should I throw this one out?
Yes. Is there one in there? We'll get more tomorrow. Yeah, these markers die kind of fast, so as they die, we'll have to just go. So simplify first, and then we'll work on solving.
Oh my gosh, this one's out too.
I can throw out the other one, that's dry.
Oh, yes.
Good, so now, that's perfect distribution. Good, now can we solve? The idea is variables on one side, constants on the other. Great. Wait, hold on, that's a 2. So when we add this, my only recommendation would be like make sure you're adding the variable too, because like that matters. Because you want to make sure that you don't add a constant to a coefficient, or I'm sorry, a constant and a variable together. So if you're going to add 9, you do it in 9x. So that's a negative 8. You should add 9x.
So when you're distributing here, the 2, and then you're distributing to the negative 4x.
That's perfect. But why here? You're dealing with 2 sides of the equation, not 2 on one side.
So like I was assuming that in order to get x by itself, this is the negative 8, so you add 8 and then do the same thing.
But if that's, what's the operation with x and negative 8? Okay? If they're touching like that, what does that mean?
You're multiplying,
Good, so then to undo that, what do you do?
right? But then how do you divide 4, 8?
Do you want to do that yet? Because this is my problem right now. I want to get all my variables on one side. I'm like, constants on the other side.
Oh, okay, so you want to keep this 14 here.
For now.
Can we do anything with anything?
Well, your first thing, so negative 8 plus 9 is a positive. So this is my equation. 3 equals x plus 14. So now how would you solve that? That was your equation.
So this is from this side, this is like from this side.
So if you want to like put all of your variables inside,
While you are finishing, I'm just going to show the distribution. It seems that we are all pretty comfortable with the distribution here. And we were, a lot of us were here.
Yeah.
Good. Yeah, exactly where we want to be. From here, and this is where a lot of us tend to get a little confused. Completely normal. Okay, completely normal. What you're used to doing in 7th grade and even last week was identifying what's happening to our variable and then undoing it, which is what we ideally want to do. The problem right now is that we have variables on both sides. What do we need to do first, just in words? What do we have to do with those variables?
Get them on one side.
We want to isolate our variables to one side of the equation. How can I do that? How can we isolate our variables? So on this side we have negative 9x, and on this side we have negative 8x. What can I do to try and isolate them? Or we may use the term move them, or remove them, or get rid of them. However you really want to say it, but the idea is you're isolating. What can I do?
Well, I added 9x.
So Shirley started by adding 9x. If you add 9x to the left side of your equation, how many x do you have over there? None. Mission accomplished. We already removed an x from one side of our equation. But I'm not done yet. If I add 9x to the left side, what must I do to the right?
Add 9x.
Add 9x. Perfect. So now, at this point, I'm going to rewrite, and you do not have to follow my own strategies. However, for me, some of these equations get crazy. So I really make it clear what's going on. I'm going to rewrite my equation with everything that is remaining. I have 3 on the left side of my equation, and the right side of my equation is x plus 14. Now, for those of us that really like to have 1x, you could do that. You don't have to. Now, at this point, how would you solve for x? Jamie?
I subtracted from 14.
You subtracted 14, so what did you have to do to the other side of the equation?
And then you have to subtract 14.
So I'm going to rewrite again. I have an x on the right side of my equation, and what's on the other side? Negative 11. So my solution here is negative 11. Did anyone do this differently? Darwin, let's see what Darwin did. So let's say 3 minus 9x equals negative 8x. Now, Darwin is not wrong. He got the right answer, but let's see how he did. What'd you do?
So first, I subtracted 3 from both sides.
Okay, Darwin started with this constant. So Darwin really established here that his constants are going to be on the right side, which means where would his variables be?
On the left side.
On the left side. So his goal now has to be to move his variables, or isolate them.
Good afternoon, Lakewood Middle School. Now our afternoon announcements. Alan Jefferson, please make your way to the main office. Alan Jefferson, please make your way to the main office. Lakewood boys soccer game's been canceled for today due to the weather. Tomorrow's game is still on. Please remember to bring your equipment. Once again, boys soccer game is canceled for today due to the weather. Tomorrow's game is still on. Please remember to bring equipment. Girls, your game for today has been canceled as well. All after-school sports actually have been canceled. All after-school sports have been canceled for today. Once again, girls soccer, please make sure you go home immediately after school today. The game for tomorrow is going to be home. Please bring your white uniform.